everybody. I thought, well, while I had a chance, I would show you this zero force motor. You can see the coils are in a toroidal form, and the switching occurs here in the front. You can hear it. And then there's the coil circuit, Bedini coil circuit. So let me run this for you. This is only going to be a short video. I know there'll be a lot of questions on it, but you know, I haven't decided to really do any experimental work yet. Peter built this motor and did a really good job, and this thing is quite capable of really moving. So here we go. Really no back EMF associated with it. And I'm loading it right now. And it will burn your fingers off. So I thought I would just make this little short video, and I'll give you one more look at it as it slows down. The circuit. The switching is done with reeds. Peter decided to do it at reeds, and it's done at every 90 degrees. And it's a neo. Inside the rotor are 4 neo magnets, and then see it moves up, and then when you hit it, it self-starts. So thanks for watching.
Please click on the link below the video to watch the full content, if you are interested.
So last year was the first time that the John Bedini's zero force motor was ever disclosed in all its full circuitry, and we even had an opportunity to release some of John Bedini's notes going back to the late 70s, early 80s, and the first time that anybody has ever seen those, and John had always kept them to himself. And so that's where the presentation came from last year. Over the period of the last year, Yarrow has continued on this path.
This is self-explanatory. I don't even have to go through this, but everybody can read, and this is essentially the layout of what we're going to do. When he first conceptualized this, when you look at this cloverleaf shows the interaction and the play of the magnetic fields that are induced within his zero force motor. But there is something very interesting that happens internally in it. 2016, zero force motor, created by Peter Lindemann, I guess in 2006 or somewhere in that era. This was John Bedini's baby. Very nice, very well put together. I went in and spent quite a bit of time, and we finally produced this guy right here. So now that you have the basics of the machine, it's like, how does it work? This is a slide, this is a diagram that was put together by Peter Lindemann, and it's very self-explanatory. It shows you essentially, here are the 2 coils, and here are the rotors. The rotor with the magnet configuration, north, south, south. And when you fire this up, let's say for example, in this mode right here, let's say we fire this up, energize it, so we create a south face right here of the coil. All of a sudden you have a kick. That rotor then spins up to this point, and then the coil stops firing. And this is the attractive node, and this is the repulsive node. We're talking the yin and yang of things here. There's no music with this. This is the machine in operation. We got it locked in fairly well in this instance. This is pushing somewhere around 8,000 RPM. This right here, what you're seeing is my computer that's taking amperage directly from the coil through a touch sensor that we have. It's a small Hall effect device that I love using because I don't have access to a $4,000 oscilloscope except for once or twice a year. And I use this. Now, a little bit more detail now. This is getting into the nitty-gritty here. You ask yourself, I ask myself, is what happens when we jack up progressively the voltage on the machine?
Please click on the link below the video to watch the full content. If you are interested